Hello, welcome to the first lecture of week 7 of Introduction to Logic Online, Philosophy 1500.02. This week we're going to be constructing truth tables for arguments to determine whether or not they're valid or invalid, right? So this is what we've been building up to for most of the course so far. So it's really exciting to be here. In any case, or more seriously, I guess, it is exciting to be here, right? All of our work's going to pay off. We're finally going to see a mechanical way to figure out whether or not an argument is valid or invalid, right? So just before we start, there are a few things to mention. So one of them is that these lectures presuppose that you know the truth tables for the logical connectives, right? So if you don't know them, right, you need to go back and learn them. Right? Otherwise, this is going to make no sense, or it's going to be very difficult, and you're just going to flail around and fail. Right? So make sure that you know those truth tables, like top to bottom and bottom to top, right? Inside and out, whatever sort of way you want to describe it. Make sure you know those, right? Memorize them. Okay, so what we're going to do, right? We're going to construct truth tables for arguments, like I said. So let's get started. All right, so here's the big idea, right? We're going to use truth tables to test arguments for validity. Like I said, this is mechanical in the following sense, right? As long as you do it correctly, you'll always be able to tell whether or not an argument is valid or invalid, right? So this is really like new, right? So we started off with sort of imagination, right? Could you imagine a situation in which the premises are true and the conclusion's false? Well, this is a not very good way to figure out whether or not arguments are valid or invalid, right? Because we don't have a lot of time, perhaps, to imagine, right? Sometimes it's hard to imagine, right? But it's not impossible. But in any case, you know, we're better or worse at imagining, so it wasn't sort of foolproof, right? And then we moved to counter models, right? Or counter examples. And this allowed us to tell whether or not arguments are invalid, right? As long as we could construct a counter model. But it's not always the case that we're able to do it, right? Maybe we're not sufficiently clever or whatever, right? And also, it wouldn't tell us whether or not arguments are valid, right? So just because you can't come up with a counter model, right, given sort of human limitations or whatever, doesn't mean that the argument's valid, right? There might be one, it's just like you haven't thought about it yet. So what's significant about the truth table method, right, is that it's always going to tell us, if we do it correctly, whether or not the argument's valid or invalid. Right, so it's a huge advance on what we've been doing. So this is really exciting. All right, so by way of review, right, you should know this already. An argument is valid if and only if what? So say it with me. An argument is valid if and only if it is not possible for its premises to be true and its conclusion false at the same time. Right, so what we're going to be doing, right, with that in mind, is using a truth table to determine the truth value of premises in the conclusion of an argument. Right, so we'll construct these truth tables, and then for each statement, right, that makes up the premises in the conclusion, we're going to build a truth table, right, and then we're going to look at the different possibilities, right, the different rows, right, and see where it's true or where it's false, right? So if there's a row, right, where the premises are true and the conclusion's false, then that means it's possible for the premises to be true and the conclusion false, right? And if it's possible for the premises to be true and the conclusion false at the same time, right, then we know that the argument's invalid. Oop, I see a typo. If it is impossible, sorry. Right, so if it's not possible, right, then we'll know that the argument's valid. So what does that mean? Well, it means that we're going to see if there are any rows, right, where the premises are true and the conclusion is false at the same time. If there's any such row, right, then the argument's invalid. But if there's no such row, right, there's no row where the premises are true and the conclusion is false, right, then we can conclude that it's not possible for the premises to be true and the conclusion false at the same time, right? And if it's not possible for the premises to be true and the conclusion false at the same time, given the definition of validity, it follows that the argument's valid. Okay, so let's sort of unpack these a little bit more. Right, so if it's possible for the premises to be true and the conclusion false at the same time, then we're going to know that the argument's invalid. right? Think about it. Each row of the truth table represents a different possible situation, right? Each row represents a situation in which the simple statements that make up the statement or the argument or whatever, right? Each row represents a different combination of truth values for those, right? So what we're looking for, right, is a row where the premises are true and the conclusion is false, right? That would be a row that shows that it's possible, right? It's a possible situation where the premises are true and the conclusion's false, right? And if we can find such a row, then we know that the argument's what? That's right, invalid. Right, so again, if there's at least one such row, then the argument is invalid. Right? If there's no row like that, right, where the premises are true and the conclusion's false, then the argument's valid. Right, so if it's not possible, right, there's no possible situation where the premises are true and the conclusion is false, right, remembering that the possible situations are represented by the different rows, right, then we're going to know that the argument's valid. Right? So that is, if no row has true premises and a false conclusion, then the argument is valid. Okay, so again, what we're looking for when we construct these is one row, at least one row, where the premises are true and the conclusion's false. Right? If there's such a row, the argument is invalid, right? Because it shows that it's possible for the premises to be true and the conclusion false at the same time. Right? But if there is no such row, right, then the argument's valid. Right? There being no such row shows that it's impossible, right? Not possible for the premises to be true and the conclusion false at the same time, right? And that's just the definition of a valid argument. So here's something that's really important, right? And I've stressed this, but I'm going to stress it again, right? If there's even just one row where the premises are true and the conclusion is false, then the argument is invalid, right? All we need is one possible situation, right, where the premises are true and the conclusion is false, and that shows that the argument's invalid, right? Perhaps there are other rows, right, where the premises are true and the conclusion is true, right? But if there's even just one row where the premises are true and the conclusion is false, then the argument is invalid. Here's another thing that's important, right? The argument is either valid or it's not, right? It's not valid in one row or situation and invalid in another, right? So validity or invalidity, right, as the case may be, it's as though it's a property of the entire truth table, right? The truth table, think about it this way, shows us all of the possibilities, each row representing a different possibility, right? So if there's any one row, right, where the premises are true and the conclusion is false, and the argument's just invalid, right? Invalidity, or saying that an argument is invalid, is making a claim about all of possibility, right, or about all of the possible combinations of truth values for the simple statements, right? And similarly, saying that the argument's valid is making a claim about all of the possible situations, right? In the first case, saying that an argument is invalid, right, is saying that there's at least one row where the premises are true and the conclusion's false, right? One possible situation, at least, where the premises being true doesn't entail that the conclusion is true, right? And when we say that the argument's valid, we're saying something like, in all possible situations, right, if the premises are true, the conclusion has to be true as well. All right, so here's what we're going to do, right? We're going to build a truth table for an argument. Then we're going to use that truth table to determine whether the argument's valid or invalid, right? And again, if there's any row, right, any possible situation where the premises are true and the conclusion is false, then the argument's invalid. If there's no row, right, where the premises are true and the conclusion is false, then the argument's valid. So let's start with an example. So here's an argument form that we've encountered before. If P, then Q, P, therefore Q. Okay, so this argument is called modus ponens, or this argument form. Not super important that you know it, but be able to recognize it, right? It's a very common argument form. Let's see whether it's valid or invalid. So here's how we'll do it. We'll begin by setting up a truth table. Okay, so this truth table has 4 rows. So why does it have 4 rows? Well, so think about it. It has 2 simple statements, right? And the way that we figure out how many rows there are, right, is 2 to the n, where n is the number of simple statements. So 2 to the second power is, well, 4, right? So there are 4 rows. So we set it up the way that we have been setting up on the left-hand side, right? Under P, we put T, T, F, F. Under Q, T, F, T, F, right? So those are all the possible combinations of truth values. Okay, so here's what we do now, right? We have our premises, premise 1, if P then Q, premise 2, P, and premise 3, or conclusion, rather, Q, right? So we're going to set our truth table up something like this, right? What's important is that we block off the different premises and conclusion from one another, and I've just used a single straight line to do this. So going to the right, we have if P then Q, that's our first premise, and then P, that's our second premise, and then Q, right? Good. So we've set up the truth table. So the way to think about this is that we've sort of shoved everything together, right, into this one truth table so that we can keep track of how things go. Right, so step 2, we're going to solve the truth table. So go ahead and fill this in, right? This should be old hat by now, right? We go across and we just put in the truth values under the statement letters. So under P in the first row, we're going to put T. Under Q in the first row, we're going to put T, and so on. Right. So now what I want you to do is solve the rest of the truth table. Right, so there's only one connective to do. Do it on your own right now, so pause me. Okay, so you should have come up with something like this, right? This is just the truth table for the conditional. So in the first situation, T, second, F, T, T. Okay, so we've solved the truth table. So what we're going to do next, right, is look at the premises and the conclusion, right? And we're looking for any row where the premises are true and the conclusion's false. So let's start with our first row. So in our first row, or sometimes I'll perhaps say line, in our first line, our first row, right, our first premise is true, that is, if P then Q is true. Our second premise is true, that is, P's true, and our conclusion is true. Okay, so is this a row where the premises are true and the conclusion's false? No, right? The premises are true, the conclusion's true. Okay, cool. So can we stop here? Does this show that the argument's valid? No, right? Remember? Saying that an argument is valid is making a claim about the entire truth table, right? It's saying that there's no possible situation where the premises are true and the conclusion's false, right? So simply pointing to one situation where the premises are true and the conclusion is true doesn't show that the argument's valid, right? We need to look at all of the other possible situations, right? And if there's no row, right, or no possible situation where the premises are true and the conclusion is false, right, then we can say that it's impossible, right, not possible for the premises to be true and the conclusion false at the same time, right? And if that's the case, then that's just the definition of validity, right? So the argument's valid, right? So let's look at the rest of the rows. So here we have our first premise false, our second premise true, and our conclusion false. Okay, so is this a row where the premises are true and the conclusion is false? No, right? Our first premise, if P then Q, is false, right? So it's not a row where all the premises are true and the conclusion's false at the same time. Okay, so does this show that the argument's valid or invalid? Neither, right? So it's just one row. It's not a row where the premises are true and the conclusion's false. If it were, right, then it would show that the argument's invalid, but it's not, right? But we can't conclude from this, just as we couldn't conclude from the first row, that the argument's valid, right? Because we haven't looked at the rest of the argument. Okay, so let's go to the rest of the argument. So for some reason I've skipped to the bottom. Let's see how this goes. But is this a row where the premises are true and the conclusion's false? No, right? What about the one above? Is that a row where the premises are true and the conclusion's false? No. Okay. So there's no row where the premises are true and the conclusion's false at the same time. Right? So that means it's not possible for the premises to be true and the conclusion false at the same time. Right? But what's the definition of validity? An argument's valid if and only if it's not possible for its premises to be true and its conclusion false at the same time. Well, we've shown using this truth table that it's not possible for the premises of this argument to be true and its conclusion false at the same time. Right? So the argument is valid. Okay, so let's think about what we did. So we began by making the truth table and solving it like any other. Right? The only difference here is that we have three propositions. If P, then Q, P, and Q. Okay, we haven't done that before, but that's fine, right? It's just basically the exact same thing that we did before, only with another statement at the end, or another proposition at the end, right? And that proposition, of course, right, is the conclusion of the argument. Okay, so you see that you could do this with more than three statements, right? So suppose your argument has three premises, right? In which case you would just add another row or another column, right? Okay, so we began by making the truth table and solving it like any other. Then we looked at each row to see if there were true premises and a false conclusion on any row, right? So we started with our first row or first line, went to our second row or second line, and so on, right? We didn't find any row or line where there were true premises and a false conclusion, right? So the argument is valid, right? Because we've shown that it's not possible for the premises to be true and the conclusion false at the same time, right? And since it's not possible for the premises to be true and the conclusion false at the same time, it means that this argument's valid. Right, so here's another example. Slightly harder than the last one, but again, it's the exact same idea, right? It's just what we've been doing before. Don't let it scare you or intimidate you. So here's our argument. If P, then either Q or R, not Q, therefore R. Right, so I've used those three lines, right, to mean that what comes after it is the conclusion. Okay, so what are we going to do here? So we're going to start by building a truth table. So pause me and build the truth table for this. You don't have to solve it yet, just build it. Okay, so you should have come up with something that, well, looks exactly like this, right? So this truth table is going to have 8 rows or 8 lines, right? So why is that? Well, because there are 3 simple statements, P, Q, and R, right? And we figure out the number of lines or rows, right, by the formula 2 to the n, where n is the number of simple statements. Here it's 3, so 2 to the third power is 8, right? So this is what your truth table should look like. So far, so good. We've built our truth table. So the next thing we do is what? Well, we're going to solve it, right? So we'll break that down into smaller steps. So first thing that we should do is what? I'm going to assume that you said put the truth values underneath of the simple statements. So why don't you do that, right, and we'll see where we get to. So pause me, fill in the truth table for the simple statements. All right, so this is what your truth table should look like right now. Okay, so we've gone through and we filled in the simple statements' truth values. So what's the next thing to do? Well, it's to solve for the individual statements, or propositions, right, for the first premise and the second premise and the conclusion, right? So why don't you go through and you do that right now? So pause me and do that. Again, it's really important that you practice this. So here's how I would do it. I would start here for no particular reason. I mean, with the first premise. You could have started with the conclusion. You could have started with the second premise. But I'm going to start here in the first premise. And what are we going to do? Well, we're going to work from the inside out, right? So we're going to solve for this wedge, right, in Q and R, or Q or R, rather, in the consequent of if P, then Q or R. Okay, so this is just an application of the truth table for the wedge, right? When at least one of the disjuncts is true, the whole thing is true. Right? So you'll note that in the first line, second line, and third line, it's true. In the fourth line, it's false. In the fifth, sixth, and seventh, it's true. And then in the eighth, it's false. All right, so next we solve here, right, which is to solve for the entire first proposition, for the first premise, right? So to do this, right, you're going to use your truth table for the horseshoe. So why don't you do that right now? So pause me. All right, so here's how you should solve it, right? We'll use the information under P that's highlighted in green and the information under the wedge that's highlighted in blue, right, with our truth table for the conditional, right? So this should be old hat by now, right? But here's how we would do it, right? And this is what you should have come up with. True, 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 false, true, 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 right? So whenever the antecedent is false, as in the last four lines, right, the conditional is true, right? And whenever the antecedent and consequent are both true, right, it's true. But when the antecedent is true and the consequent is false, as it is in line 4, right, it's false. Okay, so let's think about what we've done. We've built our truth table, we've put in the truth values for the simple statements, and we've solved for the first premise. So what should we do now? Well, obviously solve for the second premise and the conclusion. So let's do that. Okay, so pause me and solve for those. All right, so this is very easy, right? We're just flipping the truth value from true to false and false to true in both cases, right? Because we have that tilde there, right? So under not Q, right, you just flip from true to false and false to true, right? And similarly for not P. Okay, so once we get to this point, we've solved the truth table, right? So what do we want to do to figure out whether or not this argument is valid or invalid? So here's what I hope you said. We're going to look at each row and determine the truth value of the premises and the conclusion, right? If there's any row where the premises are true and the conclusion's false at the same time, right, then this means that the argument is, that's right, invalid, right? But if we can find no such row after going through the entire truth table, then the argument is, that's right, valid, right? So let's get started. Okay, so what we want to do is identify the main connectives in each premise and the conclusion, right? Because these are going to be the columns underneath the yellow highlighted bits that are relevant to us, right? So we're going to look under the horseshoe, that tilde, and then the second tilde, right? And see if we have two T's followed by an F, right? If we do, then we have a row where the premises are true and the conclusion's false, right? And that would show us that the argument is, that's right, invalid. So let's get started. So again, these are going to be the truth values that are of interest to us. Right, so let's start with the first row. Okay, so here's row 1. Okay, so we have a T, an F, and an F. Okay, so is this a row where the premises are true and the conclusion's false at the same time? No, right? So first premise is true, second premise is false, conclusion's false. So this isn't a row where the premises are true and the conclusion's false, right? Because the premises aren't true. Okay, so that means that we can move on to our next row, right? We haven't found what we're looking for. So here we are in row 2, right? When P is true and Q is true and R is false, right? What do we have? Well, we have a true first premise, that is, if P, then Q or R is true. A false second premise, that is, not Q is false. And then a false conclusion, that is, not P is false, right? So is this a row where we have all true premises and a false conclusion? No, right? Our first premise is true, but our second one's false, right? So this row is okay, so we can put a check next to it. Okay, what about the third row? So look at this one and see whether or not it's a row where the premises are true and the conclusion's false at the same time. What do you know? It is, right? So here our first premise is true, our second premise is true, and our conclusion's false. Do you see that? Okay, so what does this mean? Well, in the third line, or the third row, right, the premises are true and the conclusion's false. Now, an argument is valid just in case, or if and only if, it's not possible for its premises to be true and its conclusion false, and it's invalid otherwise, right? So this row or line shows us that it's possible for the premises to be true and the conclusion false at the same time. So that means that the argument is, that's right, invalid. Okay, so let's think about this. Why is it the case that the argument's invalid? Well, it's because it's possible for the premises to be true and its conclusion false at the same time, right? When P is true and Q is false and R is true, right? Our first premise is true, our second premise is true, and our conclusion is false, right? So just looking at this one line, right, we can tell that the argument's invalid, right? Because this line or this row represents the possibility where the premises are true and the conclusion's false. And that's all we need to know whether the argument is valid or invalid, right? So now we know that the argument's invalid, right? Just by looking at this one line, right? So at this point, you could stop, right? You don't have to keep going, right? Because one row, just one row, right, where the premises are true and the conclusion's false, shows that the argument's invalid. Right, so here's the explanation again, right? When P and R are true, but Q is false, right, then our first premise is true, our second premise is true, and our conclusion is false, right? And that shows that it's possible for the premises to be true and the conclusion false at the same time, right? And if it's possible for the premises to be true and the conclusion false at the same time, then the argument is invalid. Here's something that is important to note. Right? Look at the seventh line or the seventh row, right, where P is false and Q is false and R is true. So I've highlighted this in blue, right? So here the premises are true and the conclusion's true. This does not mean that the argument is valid, right? There might be just by accident, right, that the premises are true and the conclusion is true. But this doesn't show that the argument's valid, right? Because there is this row that we already saw where the premises are true and the conclusion's false. Right? And if there's any such row, no matter what the rest of the truth table looks like, right, the argument is invalid. Right? So it's just an accident, right, that the premises could be true and the conclusion true at the same time. Right? There's no logical necessity that flows from the premises into the conclusion or whatever. Right? It is possible for the premises to be true and the conclusion false, so the argument is invalid. Again, it's just an accident that the premises are true and the conclusion is also true, right, in this seventh line or in the eighth line, if you look. Okay, so sort of summary again, right? Remember, what we're looking for is a row where the premises are true and the conclusion is false, right? If there's no such row, then the argument is valid. But right? If there's a row where the premises are true and the conclusion is true, you cannot conclude that the argument is valid, right? You have to look at the rest of the truth table. And if there's any row, again, any row where the premises are true and the conclusion is false, then that means that it's possible for the premises to be true and the conclusion false at the same time, right? And think again about our definition of validity. An argument is valid if and only if it's not possible for its premises to be true and its conclusion false at the same time, right? So if there's any row, again, any row where the premises are true and the conclusion is false, then that means that the argument is invalid. So think about it. It could be the case that 7 out of 8 rows, right, when the premises are true, the conclusion is true, right? But if the 8th row is such that the premises are true and the conclusion is false, the argument is invalid. All right, so here's a sort of special example. So here's our argument. P and Q, it's not the case that P and Q, therefore Q. Okay, so what I want you to do is set up the truth table and solve this, right, on your own. And then when you're done, turn this back on, and I'll be here and I'll walk through what we should have come up with. And also, like, figure out whether or not this argument is valid or invalid, right? Remember, what you're looking for is a row where the premises are true and the conclusion's false. If there's such a row, the argument is invalid. If there isn't, the argument's valid. So get to work. ignore this slide. Okay, so let's get down to business. So this is what you should have come up with, right? This is what your truth table should look like. You go through and you fill in the truth values under the simple statements. That should give you this, right? And now what are we going to do? Well, we're going to solve for the individual premises and conclusion, right? So you might start with the first premise, and there we have true, false, false, false. And then in the second premise, we're going to work from the inside out, right? So we have true, false, false, false again, right? And now we have to solve for the tilde. And then we should have false, true, 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 right? Because the tilde is going to switch the truth value from true to false and false to true. Okay, so we've solved the truth table. Right, so now what do we want to do? Well, we want to look at the truth values of the proposition, or of the first and second premises rather, in the conclusion, right? And remember, what we're looking for is a row where the premises are true and the conclusion's false at the same time, right? If there's no such row, then the argument is valid. Then the argument is valid, right? But if there is a row where the premises are true and the conclusion's false, then the argument's invalid. So let's see what we come up with. So where are the main operators? Well, in our first premise, it's the dot. In our second premise, it's the not, or the tilde, right? So why is that? Well, it's the last thing we solved, right? So we're going to be looking in the columns underneath the dot in the tilde, right? That's the relevant information, along with the information under Q, our conclusion. All right, so think about our first row. Is this one where the premises are true and the conclusion's false? No, right? Second premise is false, first premise is true, conclusion's true. So it's not one where the premises are true and the conclusion's false, because the premises aren't true. So good, we can put a check here. This one checks out, it's fine, we can move on. What about this one? Are the premises true and the conclusion false here? No, right? One of the premises is true, the other one's false, the conclusion's false. Well, this isn't a row where the premises are true and the conclusion's false because the premises aren't true, right? So do we put a check or an X here? That's right, we put a check. Okay, third row, or third line, right? So false, true, true. Is this a row where the premises are true and the conclusion's false at the same time? No, right? One of the premises is false, so the premises aren't true. So do we put a check or an X here? That's right, a check. And now we can move on to our final line. Is this a row where the premises are true and the conclusion's false? No, right? One of the premises is false, one is true, right? So it's not a row where the premises are true, right, and the conclusion false. So do we put a check or an X here? That's right, we put a check. Okay, so let's think about this, right? Is there any row where the premises are true and the conclusion's false? No, right? We have 4 checks. But is there any row where the premises are true and the conclusion's true? Is there any row where the premises are true and the conclusion is false? No, there isn't, so the argument's valid. Okay, so here's a question. Is there any row where the premises are true and the conclusion's true? No, right? So why is that? Well, the premises are contradictories, right, as you should note from last week, right? So it's not possible for the premises to be true at the same time. Okay, but think about it this, right? If it's not possible for the premises to be true, right, then is it possible for the premises to be true and the conclusion false at the same time? Well, no, right? Now, think about validity, right? An argument is valid if and only if it's not possible for its premises to be true and its conclusion false at the same time. Okay, so is this argument valid or invalid? So we've already said it's valid. What can we conclude about arguments with contradictory premises? Well, we can conclude that they're all valid, right? Because it's not possible for the premises to be true and the conclusion false at the same time, because it's not possible for the premises to be true, right? So any argument with contradictory premises, right, is automatically valid. That's a little weird, right? But it fits the definition. Right, so remember, an argument is valid if and only if it's not possible for its premises to be true and its conclusion false at the same time. in arguments with contradictory premises, it's not possible for its premises to be true, right? So it's not possible for its premises to be true and its conclusion false at the same time, right? So every argument with contradictory premises is valid, right? This argument in particular is valid because it's not possible for its premises to be true. Okay, so again, the takeaway, arguments with contradictory premises are all valid. Okay, so I'm going to start including some things in the lecture that are maybe like more advanced, right? I think they're interesting. I hope you do as well, but here's a very informal sketch of a proof, right? So if two of the premises of some argument are inconsistent, then simply adding new premises will not make them consistent, and the argument will still be valid, right? So no matter how many premises you have, right, the idea is, if two of them are inconsistent with one another, or contradictories, right, then it's not possible for the premises to be true and the conclusion false at the same time, right? So you can add all the premises you want, right, but you're never going to make the premises consistent, right? So if it's inconsistent, right, then simply adding new stuff isn't going to make it consistent, right? So no matter how many premises you add to this argument, right, the argument's still going to be valid. Okay, so let's go back to the main thread. So here's our review, right? So the lecture's almost done. So an argument is valid if and only if it's not possible for its premises to be true and its conclusion false at the same time. So the big idea, remember, was that we can use a truth table to determine the truth values of premises in the conclusion of an argument, right? And in so doing, we could figure out whether or not the argument's valid or invalid, right? So if it's possible for the premises to be true and the conclusion false at the same time, right, then we know that the argument's invalid. So what we would be looking for in our truth table for the argument is a row where the premises are true and the conclusion's false. If there's any such row, then the argument's invalid. Right? If it's not possible, right, that is, if there's no row where the premises are true and the conclusion's false, right, then the argument is valid, excuse me. Right. So here's the really important point, right, that students almost invariably will mess up, right? If there's even just one row where the premises are true and the conclusion is false, then the argument is invalid, right? There may be all sorts of rows where the premises are true and the conclusion's true at the same time, right? But if there's just one row, even one, right? Even one, where the premises are true and the conclusion's false, then the argument's invalid.